Of course, everybody now is talking about machine learning and how the robots will take over life. Lots of movies talked about how artificial intelligence will advance and affect our lives for better or worse. This got all people thinking, is that really what's going to happen? How does machine learning work? Well, that's not what we're here to answer, unfortunately. We're here to give you, the one who is interested in machine learning and data science, a hands-on experience on how to develop machine learning and use it to solve real life and important life problems. Yes, we'll give you some basic concepts and theory in machine learning and its related fields, but we will not dig deep into them. In normal coding, you tell the computer exactly what to do, and then it will do it very precisely. But there are lots of situations or problems that this won't be an option. It might be that the problem is too complex that you can't write a specific set of rules or instructions to give. Also, it might be that the process of you giving the time and effort to define and set these rules is not worth it. Or you don't have much time and need a fast answer. The diversity and complexity of the problems makes it truly hard if you don't seek help in some other way. This is where machine learning comes in. Machine learning is the science of making the computer or a machine learn from data and act on their own upon this experience. As you can see, the core of this process is the data itself, and the machine learns from it on its own. No specific coding involved. To make a machine learn, we have three important parts to consider: data, algorithm, and model. Simply put, the model uses the algorithm, which is the technique on how to learn from data, to learn from the data. After this learning process, your model is well trained and can predict other new data entries. It might seem straightforward, but it's truly not. Picking the right algorithm to use is a challenge. Filtering the data to be ready for the model to learn on is another challenge. Boosting the model's accuracy is another challenge. Let's take an example on how this works. Say you need the computer to identify you by face recognition using a camera. Could you identify the set of rules to tell the computer how to do so? Most likely not. Even if you do, it will be a headache trying and you'll take a tremendous time, so normal coding is not an option. So you go with the machine learning approach. You get 50 images of yourself, including your face, the data, and you create a model with some algorithms that breaks images down and get important features out of them. And using some algorithm, it trains on these numbers and comes up with the set of rules itself so it can identify your face. Now you can use this model for your purpose. It can now do the task as it learned on it. Now let's talk about the process that you as a developer take to create a machine learning model. Number one, you first set up your data, which includes reading the data, cleaning it, removing noisy value, add some missing values, etc., and getting the important feature out of it. Next, choosing the right algorithm. There are lots of algorithms out there. You need to choose the right one based on the input data and the output you want. Some of them are quick in learning but slow in predicting. Some are the opposite. According to your situation, you'll identify what you need. Then creating and teaching the model. Here you give data to a model that uses the algorithm you choose and start learning from it until it's finished. After that, you test your model. You now test the model by providing a new data that it didn't know about and measure its accuracy and efficiency. If it's good, congratulations, you're done and now can use it. But it might need some changes, more data modification, another algorithm, another set of data, etc. In this case, you kind of repeat the process above until you're done. Finally, Once you're done, you can now use the model you've created, predicting and solving the problem you want. Machine learning has a lot more than we talked about, but we think that's enough talking. Let's start doing. And you will understand more while practicing and seeing the process in front of you step by step. But first, let's talk about Python a little bit. Python is a great language when dealing with machine learning. It has so many useful packages that we can use to create our machine learning model. Let's see some of these packages in action. First, Numpy. Numpy is the fundamental package for scientific computing with Python. It has tons of functionalities in statistics and mathematics. Make sure you have it in your machine using pip install numpy. So in the command line, I'll type the command pipe install numpy. Hit enter. Wait for it to download and install. I already have it. So let's import numpy and play with it. NP is the most famous alias for numpy, and we will go with that most of the time in this course. And the most powerful point in numpy is the array. So the command np.array has the attributes and properties that will make you love it. Let's check them. Let's put a equals np.array parentheses, and let's create a list, and remember that we should use the brackets here. So 1, 2, 3, 4, 5, 6. That's enough for now. So for simplicity, we call them ND arrays, short for number of dimensions. Since we can make them in any number of dimensions, let's save this file here, and let's just call it arrays.py. I'll save it somewhere here. And now I can go to the Python shell, open that file, and play with it a bit. When saving the file, I should just put the quotes, so arrays.py between quotes. And so I'm going to add a few lines here. So we can print the array's number of dimensions by calling a.nd number of dimensions, so ndim, and let's print that. We can also, before that, we can try printing a itself. So I'll print a, and then here I'm going to print this expression. So print, and now let's try and run this. So here we have the array a, 1, 2, 3, 4, 5, 6, and the number of dimensions is 1. Let's come back to the file and let's find its shape. So we can just print a.shape. Oops, got a typo here. And let's run it. So F5, save it and run it. So this time here we have the array a, 1, 2, 3, 4, 5, the number of dimensions 1, and the shape. Another powerful feature of NumPy arrays is that we can change the shape of an existing array. So for example, a one-dimensional array forming it to 2 dimensions and vice versa. So np.arrays has a function called reshape for this process. The function num.array.reshape takes the new shape of the array as a tuple, so rows number, comma columns number, and returns a new copy of the array with the new shape. Let's try this out. So I'm going to open up the file here. So b equals a dot reshape and this time let's put the tuple 3 comma 2 and let's try to check b. Oh, got a typo here. So I said b equals, and then now we can print b. So let's run this. Here we go. So we have a and then the number of dimensions and the shape, and now we have b. So b is the new array created by reshaping a, if you would. Now we can check the shape of b. So let's print b dot shape, and guess what? So it won't be 6 elements in 1D array. It says 3 comma 2. It means 3 rows and 2 columns. Now I have a question for you. What if we wanted to change a value in b like this? So b 0 0. Guess what's going to happen? So let's print b and check. So print b. Oh, the change in b were applied here. So the value here has changed. Now it's 15. What do you think will happen to a? Let's try to check this out. So print a and see what did happen. Let me run the code. Here we go. So yeah, the change in b were applied to a too. Numpy is very efficient. It eliminates processes whenever possible. That's why b is not an independent copy from a. It's just a new view. So if you want an independent copy, we will use the method .copy. So let's do that. Let me go back to the script here, and I'm going to create so c equals a dot reshape, and let's open the parentheses here. So 3 comma 2, close the parentheses, and then I'm going to call the method dot copy. So it takes no parameters. Now let's print c. Here we go. So maybe it's better to eliminate the first 3-4 lines of code, but anyway, so we just printed c, and it's a true real copy of a, as you can see here. So we printed a, this is the first line, and then we printed the number of dimensions and then the shape of a, that's here, so that's here. Then we created b, we printed it, so here this is b, and then in the next line we changed the value here to be 15, and that's the output. We print a again, so here is the value of a, and then we used the method copy to create a copy of a that is assigned to the variable c, and then we printed the variable c. So here is it. So now if we try to change a, it won't affect c, and vice versa. Let's put c index 1 0 equals to 50, and then let's print c. Let me run the code. Here we go. So here is the new value of c. Now let's check if it is the same as A. So I'm going to print A. Let me just remove few lines here. We don't need to print B, we don't need to print dimensions of A, we don't need to print its shape, we don't need to print it at all. The last thing we did here is to print the variable A, and as you can see, changing this value in C didn't affect the value that's in the first index in the variable A. So an important property for in the arrays is operations propagation. It means simple operations can be applied over all the elements one by one, and it's super fast. So here let me print A multiplied by 2. Let's save and run. And so here you see that we multiplied all the values in the array A by 2. So 15 multiplied by 2, and then 2 multiplied by 2, and 3 multiplied by 2, that's 6, and then 4 multiplied by 2, that's 8, and so on. So this multiplies all the elements in the array A by 2. And similarly, if we try print A to the power of 2, guess what's going to happen? Let me run the code, and here we go. So as you can see, this raised the power of all the elements in the array A to the power of 2. So 15 to the power of 2, 3 to the power of 2 is 9, and as you can tell, 6 to the power of 2 is 36, etc. So that's interesting, right? Remember, with the Python list, let me just create a list, and let me put the same values. So 15, comma 2, comma 3, comma 4, comma 5, and comma 6. And let's print this list to the power of 2. Guess what's going to happen? So this is not possible with the regular lists in Python, and as you can see here, we have a syntax error. That's all for this lecture. Thanks for watching, and I'll see you on the next one about indexing.